Let's go through LeetCode 2568, minimal impossible OR. For this question, it gives us an integer array nums, and we'll say we can use this kind of nums, the number in nums to OR to get a new number. It asks the minimal positive non-zero integer that is not expressible from these nums. That means if we use some of the num to OR, and what is the minimal number we cannot use, for example, num1 or x nums2 or those kind of OR expressions. And so, for example, 1 and 2, right? 1 and 2, they can OR to be 3. So the minimal, you say that the number are all positive, and so they can OR to 3, and the minimal, which cannot be OR, will be 4. And the second one, we'll say 1 is not included. So all of the number is cannot all of the combinations cannot be cannot OR 1, right? So for this question, actually, we'll say if in these nums, it says that the things that it can also just have this single number, right? So it also counts the OR result. So for this question, 1, 2, and 1 OR 2 is 3. So the minimum one is 4. So what we're thinking about is that we check, for example, 1. 1 is a minimal non-zero integer, right? If it's not exist in these nums, then return 1, right? And for every numbers A and B, A or B should always greater equal if they are not 0, should always greater than A and greater than B, right? So let's look at the characteristics about OR operations. For example, there is 1, right? And there is 2. And I will say 1 OR 2 can form what? Can form 3. And but they cannot form 4, right? Then the next one, we need to check if there is 1 and 2. We don't need to check 3, right? The next one we need to check is that 4, right? And the previous number, we use a 1, 2, 3, and 1 is 0, 1, 2 is 1, 0, and 3 is 1, 1, right? And 4 is 1, 0, 0. And you'll see we can use any of the combinations. For example, 4 and 1, that is 5. 4 and 2, that is 6, right? 4 and 7 is 4 and 3 is 7. So if we have 1, 2, 3, 4, that means we can OR to 5, 6, 7. And the next we need to check is 8, right? So by look at this kind of sequence characteristics, what we need to check is that is 1, 2, 4, 8. And also from 1 to 8, we can OR to be 9, 10, 11, 12, 13, 14, 15, right? So next one we need to check is 16. So what we need to check is that we look at these nums, whether there is 1 exists, whether there is 2 exists. If 1 does not exist, so we find the first one, just this is actually 2 to the power 0. This 2 to the power 1, right? This 2 to the power 2. And we find first this kind of number missing, then we return the first one will not forming. So right, so we can write code for this. We put this one into set so that and then we compose to the power numbers. Then we'll say int current equal to 1, right? What we do is that for int I equals to 0, I smaller than 22, I plus plus, then we'll have a current left shift 1, right? Or we'll have a current multiple equal to 2, right? So that's the same thing. 1, right? So we just check if set doesn't contains current, then return current. So this is to the power number, return current. If every numbers has been included, we just return -1. Let's convert this to Python. Python, for this list, we can use num set equals set nums, right? Can convert use a set variable and a current equals 1. And for I in range 32, what we do is that our current shift actually is multiple equal to 2, right? This is then we just check if current not in num set return current, and in the end return -1. Okay.